So now we're going to look at graphs. So these graphs are different to the ones about, you might ask a question, for example, what's your favorite flavor of ice cream? And the choices are vanilla, caramel and chocolate, and then you just graph up all the answers. That's not what we're going to do today. What we're going to do today is graphs that are different types of graphs. So what these graphs, this is what one graph, what the information you'd get for one graph. So I'll show you now. Sorry, that was not meant to go like that. So one graph, the information you get would maybe be y equals 2x plus by 4. So that might be what one graph looks like. That's the information you get for that graph. But this is what it looks like. So it's y equals 2x plus 4, and this line over here is what that graph is. That's what that graph is. So as you can see, this is the line, and it's a straight line, as you can see, and that's what y equals 2x plus 4 is. Now, I'll use blue here, but the reason why this comes up to be this way is, well, I'll show you. So let's say, so this is the x-axis. You still got your x-axis and you still got your y-axis. So let's say we want to know, well, let's say -1. We want to know what y is at -1. So obviously the coordinate for the point at -1, so x equals -1. X equals -1. Then if we substitute x equals minus in, a bit like algebra, we get in here, we will get -2 plus 4, which is 2. So therefore y would equal 2. And if you look at it, at x equals -1, y equals 2. See, there's 2, and there's -1. So that's how you work out a graph. And if you don't believe me, you can just look, for example, at -2. -2 into here, -4 plus 4, 0. Y equals 0. -2, where's y? It's right on 0, as you can see. So, and you can just get a whole lot of coordinates, a whole lot of, you could, I think 2's enough, and you can just draw a line in between them, and there you'll have your graph. You can do 3 if you want a more sort of accurate graph. Anyway, so that is a graph. But the thing is, some graphs are a bit different. Alright, let me just say goodbye to that and goodbye to that. Alright, now, so let's look at a graph, for example, that is, we'll just go to green now. Y equals x squared. Now, just for future reference, this is a graph that you will see quite often. It's quite a, sort of like a standard graph. And let's think about this. If we have x equals 1, then what will y equal? Well, what's x1 squared? It's still 1. Let's say you have x equals 2, y will equal, well, what 2 squared is? 4. Let's say you have x equals 3, and y, so therefore y equals 3 squared, which is 9. And as you can see, we're building a bit of a pattern. Y equals 16. I won't do all of them. And these are all the coordinates for y equals x squared, and this is just the standard graph. You'll see it a lot around. So let's just look at how this looks. So these are coordinates: 1, 1, 2, 4, 3, 9, 4, 16, and 5, 25. So we're just going to have these coordinates, and let's just see if they are right. they come. I'll just try and zoom out so you can see it all. And sorry, that's not yet. It's now. I'll press return and we'll see if it's right. And it is right. So if we look at point x equals 1, point 1, so we'll just get, so here's 1, x equals 1, y equals 1. There's a coordinate there. Let's zoom out a bit. For at x equals 2, which is right over here, x equals 4, which is right over here. So at x equals, oh gee, that went a bit wonky, didn't it? At x equals, so all the coordinates are right. So those are all the coordinates, and so that is what the y equals x squared graph looks like. Now, also, as you can see, not only are all the coordinates right here, they're also right on the other side. And as you can see, it's a bit symmetrical. Now, the reason is when x equals -1, so when x equals also -1, or sorry, when x equals -1, -1 squared is 1. So if you look very closely, I can get to it. I'm zooming in, but it's not going. It'll go in a second. Yes, it does. Okay, that's a bit too zoomed in. Sounds right. So as you can see, at x equals -1, this also equals -1. You actually, sorry. So at x equals -1, so which would be right over here. This is where -1 is. It also, and I'll get my pen. It also, oh sorry. This also equals -1. To show you, this is where -1 is. It equals, sorry, it equals 1, as you can see here. And so that is why it's symmetrical, and that is the basic graph, well, the base graph I'll call it, that you use all the time of y equals x squared. So let's go back to our slide. So these are graphs, and you use them for many different purposes, and in future topics, graphs will be used quite often, to say the least. And you can have lots of fun playing with graphs, especially in the graphic calculator where it does it quickly for you. You can, say almost random thing. You can say x cubed, I don't know, divided by 3, so x to the power of 3 on 2. You get this funny graph. You can do many different things, and it's a bit of fun to play with. You can get plus that by, oh sorry, get that down, times by, I don't know, to the power of 4, and oh gee, that's an error. Anyway, you can have lots of fun with this, and I'll show you what x cubed looks like, because you might see it a few other times. It looks like a bit of a squiggly line, and you can have lots of fun playing with this. It's always fun to play with, and yeah, those are graphs.